Since I had released the recording for today's lesson, right, I'll start with the chapter number 10. So I was to start with the chapter number 9, but the thing is like it's a little difficult chapter. So let's do that online when you're available. So I just like wait for a few minutes to start because like to check the availability since not there, I'll do this as a recorded lesson for the moment, right? Okay. So then the first thing that you need to consider about the electricity, we have learned about this chapter in grade 6 and grade 7 both, right? Now you have proper idea about how this electricity works. So that is basically in a circuit. So when electrons are like some like there are two edges, anode and cathode. When electron concentration of the density is high, from that end to the low density end, so electrons are transverse. That happens. So these electrons, basically these are negative values. So it will go and it will move to the positive, move towards positive values. That is the nature. So we learn that is like in the magnetism also, this north pole attract to the south pole. Similar to that, these electrons are negative and that will be moving to the positive direction. So anyway, that is measured as electric current, right? When electrons move the one direction, conventional power we call that is moving from, let's say electron is moving from X to Y, then you can say the conventional power is moving from Y to X. That is how it is measured. We have learned this in previous 2 grades. Okay, here is a very simple circuit you can see in this activity. So it's used filament bulb, a 6-volt bulb, small one, and dry cells, that is 1.5 volt, and a switch. So filament bulb is like consuming 6 volt. So you know, like the battery is not enough. Battery is only 1.5 volt, but the thing is still you can light up the filament bulb a little, not much, but a little small brightness would be there. So the here the dry cell is connected to the bulb and shown in the figure 10.1. You can see here bulb is connected to this and there's a switch, and there is a, so this should be a voltmeter, galvanometer, because you are going to measure the voltage, right? Then the connect two dry cells with another bulb. So you can see the power is not enough. Maybe the you cannot see the filament but turn on. It's not measurable. Sometimes very light, sometimes not measurable, right? You can just experiment this. So if even if some LED bulbs will not bright in certain conditions, LED take less than 6 volt, but still, so it will not light up in certain condition when 1.5 volt, but when 3 volt given, means when there are two batteries, 1.5, 1.5, it will add, it will sum, and then there will be 3 volt. So if you measure this using voltmeter, you can see there are 3 volt. So then in the figure number 3, the next figure, three cells or 3 batteries, 3 dry cell batteries are connected. Then, so it is 1.5 plus 1.5 plus 1.5. So let's do this experiment quickly using our Tinkercad. So this is our virtual practical environment. Sign up first using my personal account with Google. Okay, we are here. Let's create a circuit design. A new one. Need a circuit there. Okay, first we need 1.5 battery, and the battery is here. Then a 6 volt bulb. I have the bulb, but I'm not sure whether this is 6 volt. Can I get the information of this? It seems not to see, but anyway, let's use multimeter to measure this. multimeter. So instead of voltmeter, you can use multimeter. Multimeter can be used to measure voltage, amperage, and resistance, all three, right? That is why it's called multimeter. So let's change that to V mode to change the voltage. And so if you want to measure the voltage, you have to connect this, and I need to switch to slide switch can be used. I think the 2-terminal slide switch is enough. Do I have 2-terminal switch? DIP switch. Push button. Okay, it's okay. Let's keep it. This is the common. This is terminal 1, terminal 2. Okay. This is common. Let's connect them. Class edge, I'm connecting that to the switch, then to the bar. Then the negative edge, let's connect that to the switch, right? Sorry, to the negative edge here, the negative edge. Let's try this, and you can see, oh, sorry. Oh, I have connected the other way. Did I connect this switch? Wait. So let's use terminal 1. And the other node to the center one. Sorry, terminal 2. This is to terminal 2. Then this when you simulate this one, turn on this, right? So both terminals are not connecting. So I have to connect that to the common one. So this will not light up because like it's not enough. It's not connected. So we have to connect this to the common one. Just connect to the common one, and here. Let's start the simulation. And when I switch on this, you can see it works, right? Switch off, switch on, switch off, switch on. So but the brightness of the bulb is not that it's very so here actually let's measure this, then you can understand. So this bulb actually we have not specifically taken 6-volt bulb. So maybe the bulb is like consuming less than 6 volt. So let's stop the simulation, otherwise we can't. So therefore, sometimes bulb is like a 3-volt bulb or something like that. That is why you have to connect to either this switch terminals, or you can just connect to bulb and measure this. Anyway, you can see only one battery is there, means the voltage will be 1.5, around 1.5, closer to 1.5. There can be small differences, but it will be closer to 1.5. You can see 1.48. But this depends, right? Depends whether if you have taken 6-volt bulb, it might not turn on, or it might not visible to you. It will turn on but not visibility. That can happen. Let's increase the number of batteries now. Now I'm going to increase the number of batteries to 2. I need 2 batteries. Right, let's measure it now. Now we can see it's getting closer to 3 volt. Stop the simulation. Let's increase into 3 batteries. Please note that how these batteries are connected here. Please note that this is a plus and minus connection. So you can see here plus, it is connected to this plus, this is minus, minus is connected to plus, and this minus is connected to plus. Actually, this is a serial connection. If I draw this, if I draw the batteries, so let's assume these are batteries. Actually, this is, it's connecting this way, right? Okay, let me mark the positive edge in the red color. If this is the positive edge of the battery, if this is the positive edge of the battery, and if this is the positive edge of the battery, please note that the positive edge of this is connected to the bulb positive edge, and the negative edge is connected to positive edge of the battery. Negative of this battery is connected to the positive of the battery, then negative will be connected to the negative edge of the bulb. So that is how the process. Okay, that is how the process moves on. So this is called serial connection. When there is a serial connection, right? When there is a serial connection, so the voltage will be sum of the voltages of all the batteries. That is here closer to 3.5 voltage because you have added 3 batteries. So actually speaking, the brightness of the bulb should increase. Brightness of the bulb should increase when you increase the number of batteries. The voltage increases. Sometimes it is exceeding the bulb voltage, bulb can burn. So if you, for an example, if you try to connect LED bulb to this setup, bulb may burn, right? You can try that. Let's connect LED. The positive edge I'm connecting to the positive edge of this, and the negative edge to the negative edge. Then the negative edge to the negative edge. This is LED bulb. LED bulb normally it can tolerate around 2.5 voltage, but this is giving like you can see it's giving 3. So this voltage will be low. The voltage will be low because there is like some amount of voltage moving through this bulb also. And you can see now this is showing this will take voltage than the expected voltage, and therefore this bulb will burn. Therefore, you have to understand the voltage of the bulb. When you are providing external voltage, understand the voltage of the bulb. Otherwise, the setup will collapse or the bulbs will burn and the electronic components will be damaged. Okay, more than necessary voltage is given. It is like you are in maybe in the lightning or thundering. So more voltage, there is a possibility to high voltage to come to your devices. And what will happen when high voltage will there, devices might burn. So if it is not protected by fuses, so sometimes it will burn only the fuses and protect the devices, but sometimes it might burn the entire. Okay, now you know the battery serial connection. So this is what the result of battery serial connection. Let's move to the next part. Right, when you connect batteries in serial way, the short like we are showing the positive edge, negative. The positive is the longest, negative is the shorter, and this is how this is how we show the connection. Right, you can see positive in red and negative in blue color, and the connectivity should be something like this, because positive to positive connection, negative to negative connection is not possible in serial connection. But in the parallel connection, all the positives are taken together and all the negatives are taken together. So then what? So then you are not actually increasing the voltage. We will keep the same voltage, but it can improve the amperes, right? Same voltage, but it can improve the ampere. So just understand how this amperage and voltage work. Voltage is like the height of a waterfall. Height of a waterfall. When the voltage is high, it's like the waterfall height is high. When height is high, you know what will happen. So if you try to bath from that waterfall, so what will happen? You can understand, right? If it is very short waterfall, if you try to bath, doesn't matter, right? Nothing like that is not damaging. That is similar to if you touch a battery with 6 volt, 9 volt, 12 volt, so you will not get electric shock. But if you try to if you try to touch 230 volt, some higher voltage, definitely you will get electric shock. That is similar to if this waterfall height is too high, if you try to bath from that, definitely you'll get head stroke, something like that, right? Anyway, you will get like it's painful. It's not easy. It's painful, right? That is what happened. That is what happened when the voltage is high. Then the amperage is similar to amount of water. So here, when you increase the number of batteries, the height increases or the voltage increases. Then the power, that what is the power behind this electricity, how powerful this electricity signal is or electricity is, that is defined by the serial setup. But the second setup will not increase the power. Instead of, it will increase the volume. Volume means the amount of amperes that it can deliver. So we need battery parallel, battery serial, both connections, right? And the bulb parallel, bulb serial connection is also there. The battery serial connection, it will not increase, understand, it will not increase the voltage, but it will definitely increase the amperage. But if required voltage is not there, the device will not work. Even though you will try to improve the amperage, if required voltage is not there, then what will happen? It will not work. So when you increase the amperage, the time that you can consume will be increased. That means if there is a large volume, let's say water, you have powerful waterfall falling from top level, maybe 100 meters falling from, it's very powerful, but you have very small amount of water. Then if you try to consume, this will be over soon. If you try to collect and consume, this will over soon because amount of the water that you are getting is low. But let's say the height is not much, but you are getting a large volume. Then if you try to collect and consume, you can consume that for a lot of a big period. So that is what happened, right? So that is, so understand with the examples how this voltage, amperage, and resistance is actually, so resistance, we learned that resistance is disturbance, kind of disturbance to this flow. Okay, let's see what will happen in the battery parallel connection and also the bulb serial and bulb parallel connection. Let's explore them now, right? Bulb serial, bulb parallel connection. Let's explore them now, and then let's learn about this simple electric circuit. This is electric torch. And before that, I would like to explore this part. Let me remove this. If you want to show that battery serial connection, still it's possible with this setup. So let me get a battery. So without increasing the battery that way, what I'm going to do is I'm going to take a battery, a normal battery, 1.5 volt, and I'll take 3 such batteries, right? 1, 2, 3 such batteries without like using that earlier setup. Now what I'm going to do, if this is serial, what should happen? The positive should connect to negative. And here also the positive should connect to negative. Here positive, let's connect to the switch. And the negative, let's connect it to the bulb, the other edge of the bulb. So this is what the serial connection is. So you can see it's showing 4.36 voltage. 4.36 voltage. That is your serial connection. Right. Then let's see the parallel connection of this. And if you measure the amperage, right, you can see this is not the way to measure the amperage, because the bulb will turn off if you try to measure, because all the ampere, the full amount of ampere will fall through this one. So if you want to measure the amperage, you should not connect this parallelly. You have to connect this serially. Actually, you have to connect through this, connect through the multimeter. If you want to measure the amperage, you have to connect this through the multimeter. Oh, there's a different option in multimeter actually. But if you connect like this, this is actually serial connection. This is to measure the amperage. You can see the amount of ampere fall through. It is 90.9 milliamperes. Actually, each. So if you reduce the number of batteries, so this will not sum up the amperage, because like this is adding the voltage. It's not adding the amperage, right? But let's remember these figures. This is 90 milliamperes and voltage is 4.3, 4 point closer to 4.5. Now let me connect the batteries other way. I'm removing this connection. Now what I'm going to do, all the positive connection I'm going to connect together. Positive to positive to positive to positive, right? All the positives I'm going to connect them together. And then these positives I'm going to connect to the positive edge. Okay. All positives to the positive. Then the negatives to negatives I'm connecting. Negative. Let's connect to negative here. And this negative need to be connected to this negative. Okay, and negative, 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 positive, positive, positive. But you are connecting, you are taking from the positive, you are taking from the negative. Let's see the amperage now. Can you see it is now 31.1 milliampere. Let's measure the voltage. Erase this. And I'm measuring the voltage. Now I have to connect this to the negative. Let's measure the voltage. And voltage is you have to connect parallelly to measure the voltage. It's only 1.5 volt. It's only taking voltage of one battery. Voltage of one battery, and when you measure the amperage is basically the number of amperes falling, and that is also closer to 3 amperes, but that is milliamperes, right? 0.3 milliamperes. Okay, but amperes need to be added, right? Actually, we didn't measure the amperage of one, but when you are connecting these batteries, this is parallel connection. When you're connecting the batteries parallelly, the ampere hours, the number of ampere hours, the time that you can use these batteries will be increased. Age figure, ampere hours. right? But the amount of like ampere that is taken is based on the consumption of the bulb, right? So it consumes a certain amount of amperage, but so you can use this for very long time. You can use this for very long time. That is where when the parallel connection. But if it is serial connection, amount of voltage will be high, but the battery will die soon. Battery will be like you want to recharge the battery soon. Okay, now I think you have basic idea about the voltage, amperage, etc. Let's move to the lesson now. Electric torch. Electric torch is essential equipment when going to go in the dark night, right? So we don't know. So that has a bulb, and it's a very simple thing, switch, and the battery is connected serially. Serially connected batteries and a bulb and a switch. Actually, why there's a reflector? Because the light generated from this should send towards this direction. The light generated need to be sent towards this direction, right? That is why, that is the reason why this reflector is used. Otherwise, it's moving here and there all the ways. It's moving, then you cannot get very good beam. If you want to get a very good light beam, you need this reflector. Anything else? Metal spring is pressing the batteries, so that is pressing and holding the batteries, and switch is to turn on and turn off. Okay. You are asked to draw the diagram. You can see there are LEDs. What is the symbol for LED? LED or diodes? There's a specialty of diodes. Diodes send electricity only one direction. But if you take a motor, it will work both direction. But if you are using a diode, the plus and minus are compulsory because it can send current only one direction. The symbol of diode is it there somewhere? No. It is triangle and a line. So this is symbol of diode. Since it is a light emitting diode, you have to draw small arrows showing the light emitting. Anode and cathode. This is anode, this is cathode. Anode is the plus edge, cathode is the minus edge, and you can show using arrows. This is light emitting. The normal diode is this triangle and line, but the light emitting diode, triangle, line, and the light emitted light. Here this side is anode, the plus, this side is cathode. When you're drawing the diagram, please use that symbol to draw it. There are 4 batteries connected and bulbs connected. Bulbs, when bulbs are connected serially and parallelly, there is a difference, right? So let me show this using circuit construction kit 2, DC circuit construction kit. Or you can use LED light emitting diodes here. This is actually when you're connecting batteries, batteries parallelly, right? If you connect LED here, light emitting diode to this anode, and let's connect the cathode to cathode. The amount of voltage it's getting is only 1.4, 1.5. Therefore, the brightness of this LED is very, very low. Here, because the voltage is low. If you can increase the number of volt that is delivered, then you can increase. If you increase the voltage, then you can increase the brightness of this bulb. But to increase that, you need some, because even amperage is enough, the voltage is not enough, and that is the reason why you cannot turn on the bulb properly, because amperage is enough, but voltage is not enough. Then what should we do? How can we improve the voltage? Actually, we have to connect the batteries parallelly, serially. Then only the voltage increases. No? Or we have to use some other batteries which can deliver more than 2.5 volt. Then you can turn on the bulb properly. Oh, okay, let's use that option. So there is a coin cell battery, but this coin cell battery is 3 volt. But the problem is when you connect the coin cell battery, the voltage is enough, but this amperage is very low. Therefore, it will soon die. The battery will soon drain, right? Then LED. Let me show. The LED need to be connected to anode. Here cathode. Let's turn on the setup, and you can see a brighter LED will be there with the 3 volt. Here, this LED is not bright. Even 3 batteries were used, but these batteries are parallel. The reason is that because it's not giving enough voltage, but here it's giving enough voltage. Therefore, you can see a bright LED. Right, then you can do the experiment by adding more LEDs. What happens if you add another LED to this? You have to connect similar way. The anode need to be connected to the positive edge, and cathode need to be connected into a negative edge. So still both are getting closer to 3 volt, but the thing is, there's a problem. Even both are getting the voltage, both will light up well, since both are getting the voltage, but battery will soon drain. So let's connect 3 LED bulbs, still possible, because like for 3 LED also, this will work. Practically also, this will work, right? With a coin cell battery, it's not expensive. You can find it for 100 rupees in market. Then just connect that to LEDs, actually 5 rupees or 10 rupees maximum. Connect them to the LEDs and see. You can use 3 color LEDs, but red will consume less current, so you can use red. Red will be better. You can see all 3 bulbs are lighten up, but battery will drain soon. Practically not doing this, but still you can see the bulb will lighten up. It's getting more than enough current also. Right, that is parallel connection. What happens if you try to connect serially, the bulb serial connection? Let me take LED similar to this, one LED and one coin cell battery again. Connecting plus to the plus edge, minus to the minus, or the cathode to minus. Let's light up the bulb. You can see the voltage is high, therefore you can see the problem mark. Anyway, bulb will not burn. Voltage, when voltage is high, the amount of the volume of or the ampere that you are getting through the bulb will also become high because of the high power voltage. It's not high power, but 3 volt. 3 volt will flow more amperage too. And then what will happen if I try to connect that another bulb serially? Let's see. Then the thing, what will happen? It will share. When you connect another LED bulb serially, that how to connect that, you can just connect the positive of one to the negative of the next, anode to cathode. Similar to the battery connection, can connect this and see this now. The brightness of the LED is really lower than the previous setup. The reason is, if you measure this using a voltmeter, totally there is 3 volt, but this 3 volt, this bulbs will take 1.5 volt, the other bulb will take 1.5. That is the problem because voltage will be divided. Similar to voltage will be voltage will be added when batteries are connected. Now, when these consuming devices are connected serially, it will share the voltage. So that will happen in the serial connection. So you need to know this battery serial, battery parallel. then bulb serial, bulb parallel connections before we start the lesson. Then the next is the keys and resistors. So let's discuss that part next day. Keys, resistors, and special resistors, and the tools that you can use for soldering and all. And normal AC power about that, and DC, it's about the DC power, and so some other components. Yeah, LEDs, and here this is symbol is given here, right? LEDs and their behaviors. We need to do the measuring current part again for some of these examples, and electromagnets using electricity. And this is not unlike a dry cell battery, and so you can see this water. So what will happen when you put dry cell battery and carbon rods to this water? So there is a chemical effects. Let's learn about that too. And here, this is like another way. So these things we can discuss next day. I'll be stopping today. Next day I'll discuss the remaining part.